just in case. So there's a lot of stuff in this 3 week or so of meteorology, you know. And this is the stuff that's going to be on the test, though, okay? So hopefully this will all kind of work for you. Oh, come back here. That isn't what I meant to do. This is what I meant to do. There you are. No, I mean it's here, but. Okay. So that first term, the Earth's covered with water, okay? So in one of my videos, I know it's hard to see. You might just vaguely recognize these from the videos you watched, okay? But 70% is what, land or water? Water, yeah, that's a test question, okay? Another thing is this graphic over here. The big sliver is oceans, and then the little sliver is freshwater. But what is the thing, freshwater, what's the most, do you guys remember? Glaciers, very good. So that's another question, okay? Okay, what else do we have? So we talked about the phase changes. We have gas, liquid, and solid. And if you're kind of going this way, from solid to liquid to gas, you kind of think of adding energy, okay? That's energy is absorbed. And when you go this way, from gas to liquid or liquid to a solid, actually energy is released. We talked about that. Okay. And then there's a question on there, actually, since you're all listening, I'll tell you it's the last part where it's a short answer. You just have to tell me what's the hydrological cycle. You know, it's the rain cycle. So you have precipitation, sun comes out, you have evaporation, condensation into clouds, okay, so that's the hydrological cycle. A lot of this stuff you already knew before you came here. Now this you may or may not have known, but remember, warm air, does it hold more or less water vapor? More. Very good. I had to think. More, exactly. And that's what this little table is showing you. I know it's hard to see, but this actually here are the temperatures, and this is the amount of water vapor that can be held at that temperature. And so as it gets colder, you decrease temperature, you decrease the amount that can be held at that temperature. And the whole concept of saturation, I like this little thing right here. The reason it's saturation is we see evaporation and we see condensation. So it's a very dynamic process, but if the amount that's evaporating is the same as the amount that's condensing, then it's at what we call they're equal. It's at equilibrium. It's air saturated. What's the relative humidity there? At saturation. 100%. 100% RH. Yep. Okay. Speaking of relative humidity, when you say 100% relative humidity, you're saying you maxed out, right? So the percent relative humidity that anybody tells you is how much there actually is, that's what the A stands for, divided by MC maximum content. So A is actual, MC is maximum. So the actual content, actually you get from the room. So I have an example over here, okay? This is an example where we just happen to have 1 kilogram of dry air. But notice that we have 7 grams of water floating around in there, okay? The temperature is given as 20 degrees Celsius. Now, if we go over here to this table and we find 20 degrees Celsius, okay, where is it? Yep, sorry, I know it looks really bad, but this right here, this is 20 degrees Celsius. You see that blue circle there? That's the max amount of water that can be held at 20 degrees Celsius, which happens to be the number 14. You can't see it very good. So that's why we divide what we actually have, 7, by what it can hold from the table, 14. Of course, you're looking at half. So that's 50%. So that's how that works. So I don't know if you maybe recognize the heat index table. Okay. Well, I don't think we looked. Did we do heat index?
Yeah, we did.
Okay.
Yeah, we remember that was in the lab.
Yeah.
Okay, good.
One with the sock.
Yeah, we did. Okay, good. Because that's coming up too, the sock. And so across the top, we have the temperature, and along the side, we have the relative humidity, and where they intersect, that's the feels like temperature. So I did an example. If the thermometer reads, what does this look like, 86, okay? Your humidity is 60, it feels like 91. So I think you guys would do fine. Okay. Why are clouds white colored? Well, it's because the gas has done something, whether the gas condensed to be a liquid or whether you have some crystals going there, some snow, which, did you guys see snow? Like, no? It snowed yesterday, last night. Okay, so.
Clouds are white, so we need to know that clouds are white because it's constant.
Yeah, it's condensed, it's liquid water or it's solid ice, and the light is scattering. The light is bouncing off of that, solid particles. If it's gas, the light just goes through. Okay, but if it's liquid or solid, that makes the light scatter. And then I have a question on there about sleet. Okay, let's see. Yeah, sleet and freezing rain. They're both kind of similar conditions. Now, what happens with both of them is it starts out as snow, it hits a warm pocket, okay, and then we have a cold pocket of air underneath here. This is what we call a temperature inversion. Okay, the word inversion means kind of backwards. This isn't usually the way it is. So there's a question on there about that. So it refreezes here. And remember the depth, it says whether it'll be sleet, if it's deep enough, or if it's really shallow, it'll freeze on contact. What's the Bergeron process?
That's how a snowflake forms.
Yeah.
Now, what's the other for a raindrop? That's, I forget what is it called.
Collision coalescence,
Okay,
maybe?
yeah.
I don't know. But the Bergeron process is basically the thing that summarizes that snow was forming. And then you'll need to know the 10 cloud types. I'll give you a hint. That will be actually, that'll be on the last part too. You'll see a kind of a graph, not a graph, a figure. You'll see a figure that looks, well, not exactly like this, but you'll have to identify the 10 cloud types.
You have to match them up.
Match them up, yep. And then fog, I talked about 4 types of fog. So probably take a look at that. They're actually, they're radiation fog, advection fog, upslope fog, and evaporation fog. So take a look at that. I think it's a multiple choice question. Which of these is not a type of fog? So be able to pick that out. And then the EC means it's extra credit. So the last page of the test, after your short answer, is going to be where you, like you did in lab. Let's see, what did you, oh yeah. So remember across the top, you had another chart, had lots of charts last week. Along the top you had the depression, the difference between your wet and your dry bulb. Okay, yep. And then along the side you had the temperature of the room, the dry one. And where they intersected, which one did we do? Where they intersected, because there's different ways to read the table. Did that give us relative humidity? I think so. But it's where they intersect. Okay? Right. So go look at your, because I think I just went ahead and grabbed the thing from lab and put it on the test. So if you look at your lab for last week, you should have it. Okay. Phew, so much in so short a period of time. Concept of an air mass, big chunk of air, okay? And we have 5, 6 different air mass types. Okay, and they vary by temperature and how much moisture they have. So source regions are over here. Okay, how do you get, for instance, a wet, warm air mass? Well, it's got to be kind of close to the equator, and it's got to be over an ocean. Okay, so these are 2 source regions for maritime tropical air masses. Okay. So I have an asterisk next to, let's see, which of these then can you find only form in the summertime? Which of these air masses only form in the summertime?
Continental, tropical, and American.
Yep. I have it, it's color coded. So summertime, continental tropical, only form 1 asterisk. Continental tropical only form in the summertime, and in the wintertime only maritime Arctic form. But I think it's the summer one I have a question about. Okay, so it kind of makes sense. I mean, continental, well, the tropical part makes sense.
So you're looking for tropical, not continental, or
Continental tropical. Yeah, that's the one that's,
maritime tropical?
No, I was wrong. No.
Oh, okay.
okay, sounds like you're okay.
Yeah.
Okay. The types of weather fronts, there are actually 4. The most obvious are the warm front, cold front, and then the stationary front is kind of the standoff. And then we talked about the occluded front. So, no, just basically that there are 4 different types of fronts and what they look like on a weather map. And then in general, if you have a cold front coming, okay, you can expect, not cold front, sorry. Yeah. A cold front, if it's going to rain, your rains are going to be intense and they're going to be short-lived with the cold front. Very abrupt frontal lifting. And then if it's a warm front, we talked about something called overrunning, and kind of your precipitation is going to last a long time. So warm fronts. Okay, composition of the Earth's atmosphere. So that pie up there shows a lot of nitrogen, a little bit of oxygen, and a dab of a few other things. Okay, so nitrogen, I guarantee, I think it's a multiple choice question, you know, what's the most common or abundant gas in our atmosphere? Nitrogen, yep. And then actually you guys had a video quiz question about this. Which are the gases that are variable? And the gases that vary are water vapor, carbon dioxide, and ozone. Nitrogen is not a variable gas. Blue skies, okay. And I might add here, and this isn't on your sheet, but I'm going to go ahead and, do you remember it starts with the letter R? What do we call? What's that?
Raleigh scattering.
Raleigh scattering, yep. Can you tell he likes meteorology? Well, many of you do, but he took a little longer class in it. So Raleigh scattering. Okay. Ozone, and I took this actually from the exam, so there's bad ozone, but this must be a question about the good ozone. Okay, you need to know the layers of the atmosphere, which is actually, I think, coming up here. Okay, but one of the layers of the atmosphere is the stratosphere. Where is the stratosphere relative to the troposphere? Do you remember? Don't answer. What do you think?
Where's the what?
Where's the troposphere and stratosphere relative to?
The
Like us?
stratosphere's on top.
Right, yeah. And the troposphere is right here, and the stratosphere, yeah. Mesosphere and thermosphere. Perfect, right, Joshua? Okay. So the good ozone is in the stratosphere, and I think the question goes something like, what's good about it? It protects us from one of the energies of the sun. Yep, you got it. So then carbon dioxide, this is a figure for carbon dioxide from like 1950 to the present day. This is that Hawaiian island thing. So carbon dioxide, we actually have 2 trends. We have the little squiggles, and what's the word next to the little squiggles? Yeah, photosynthesis. Glad you can read my writing. So the little squiggles are seasonal, and actually that's the plant activity that basically, what do plants do with carbon dioxide? I always have to concentrate. Do they take it or spit it out?
No, they take it.
They take it, yeah.
Yeah, they spit out oxygen.
They spit out oxygen, exactly. So there's a seasonal trend in plant activity. And this actually is a side note. These squiggles, right, that are seasonal variations in what the plants are doing, if you go somewhere where there's no plants, okay, you're not going to see these squiggles. I think that is so cool. I've seen some data like that. And then there's the ongoing kind of the hockey pucks sort of upward trend, and that's due to carbon dioxide created, and I wonder if I have a little thing on that. No, I guess I don't. Oh yeah, it must be over here. Okay, what is this trend due to? Well, the deforestation, we're removing our CO2 sinks and burning of fossil fuels. Then the next one, the greenhouse effect. I brought in this little figure from your notes. The greenhouse effect, basically, you have, this is the light coming down, and it comes through the carbon dioxide or other greenhouse gases. It interacts with the earth, and it heats up the earth, and then that warmth tries to go ahead and what we say re-radiate away, and that actually then interacts with the greenhouse gases. So visible light comes in, but when it changes to long wavelengths, the greenhouse gases interact with the heat. So that's what I come, and that's why, like your car, if it's sunny outside and the sun is shining through your car, you'll have a similar sort of deal. Come back. Oh, you are stubborn. Guess I gotta go wake it up every once in a while. Let's see if it'll pick up where it left off. Oh, reconnecting? That's a good sign. I know. 1001, 1002.
The trade, I guess, on trade winds on east to west too?
In the southern hemisphere,
I mean, is it same as,
the trade winds are also easterly, yep. So kind of what you're saying is we have easterly trades here, and we
Yeah,
have
okay.
mid-latitude westerlies, and we have
so
polar
they're
easterlies.
the same
Yeah.
for both? Yeah,
Yep.
okay.
Now, the trade winds kind of come from the southeast, and here they kind of come from the northeast. So, but they're both easterlies, yep. So know those, and, yeah. Trying to think what else. I guess that was it. Okay, so hopefully that's it, something like that. This one right here, I'll go back to this, is actually this is a figure. This question right here, you're gonna have a figure, it's not gonna look just like this, but again, I'm gonna number them, and you have to match the number with what the name, what cell that is, or what the prevailing wind is there, okay? Okay. Cool. So now actually onto something that I haven't recorded yet. I'm hoping to have them recorded by Saturday morning and posted, so. So one of the things you're gonna, maybe you already know, but hurricane actually is the specific name for us. The generic name is tropical cyclone. They mean the same. So tropical cyclones, depending upon what part of the world you're at, you call them different things. And I think the test question goes, I think the answer to the test question is typhoon. Okay, basically, if you are in the Indian, near the Indian Ocean, or there in Japan, they would call it a typhoon, what we call a hurricane. Okay, now deadliest hurricanes, we actually are going to watch a video on Katrina. Katrina, I think, was maybe the most costly, but it wasn't the deadliest. Katrina ranks, is it up here? Yeah, ranks third with regard to loss of life. What ranks top is actually clear back at the turn of the century, Galveston, Texas. See, we haven't always given them cute little names like Katrina, right? And actually, as you know, I say cute, but the name Katrina will never be used again because if they are notorious, they're thrown out. But yeah, we figured they didn't have any warning. And Galveston actually.
8,000 deaths?
What's that?
8,000 deaths?
Mm-hmm. There's some interesting photos of the aftermath out there. That's a lot of people. And they got hit twice, 15 years later,
Do the hurricane names go in alphabetical order?
They do, and I think that's coming up under rules to name hurricanes. I think it's interesting. Yeah, they do go alphabetical. So you're gonna read or listen in the lecture that there's three things. If your goal is to make a hurricane, then these are the three things you need to happen. A hurricane is specific. Tropical cyclone is generic. So to make a hurricane or tropical cyclone, you need warm water. No kidding, right? And actually, the warm water part, on the end of today's video, they're going to talk about the temperatures, the surface temperatures of the waters are increasing, which it's kind of a little bit controversial. Does that mean we have more hurricanes? But you need warm water, but you can't be too close to the equator because CF stands for Coriolis force. And what causes the Coriolis force? Very good. The Earth spinning. That causes the Coriolis force. So, and one of the rules of the Coriolis force is that it's basically zero at the equator and it's really effective at the poles. So if you're too close to the equator, you don't have any Coriolis force. So even though it's nice and hot next to the equator, you're not going to see hurricanes there. You have to be at least 5 degrees away from the hurricane, or excuse me, away from the equator. And the last thing is you need to have an unstable atmosphere. And that actually kind of leads to our thunderstorms a little bit. All right, rules to naming a hurricane. So actually up there at the corner you see an excerpt of a slide that you're going to see in lecture. Each basin has its own set of names. They're alphabetical, like you were saying, the ones that we're most familiar with. And they used to be all female, and now they alternate, male, female. I think that's a good thing. When it's hard to come up with a name like Q, U, X, Y, and Z, there are no hurricanes with those names. And you're going to hear in the video the year 2006 that Katrina occurred, 2005. In this season, there was actually more than the 22 hurricanes. So they had to go to the Greek alphabet. And what's that?
That's a lot of hurricanes.
That is a lot of hurricanes. But assuming that the hurricane wasn't terribly deadly, it's actually recycled. Let's see, and they retire names if necessary. Cool. And there's different ways that hurricanes bring destruction. And on the test, there must be a question, I think it's a vocab question, about the thing a hurricane does called storm surge. And you're going to hear in the video about storm surge. And if you watched on TV the whole hype, and it is hype, I mean, it's hype says like it's unnecessary. But when a hurricane is reaching landfall, they'll talk about the storm surge. And I liken it to basically if you're kind of in a pool and you take your arms and kind of go like that, you basically are taking a wave of water with your arms. And so picture basically the most intense part of the storm, which is the eye, and picture it with the most intense wrapping the water around. So it's a wall of water hitting landfall. That's storm surge.
Which side of the hurricane's at?
And hurricanes are a low pressure, and so in the northern hemisphere they go counterclockwise, and so it's kind of as I was doing this, I get my counterclockwise mixed up. That is counterclockwise, and so the worst part is actually here on the right side.
Okay.
Yep. And then we go on to something that's a little more near and dear to our hearts, the severe weather we're more familiar with. One of the things I picked on to lecture and include on your test is this idea of hail. I talked about sleet before. Sleet is not the same thing as hail. Sleet was formed by a warm pocket and then a cold air. Okay. Hail is formed with thunderstorm clouds. That's how hail is formed. So in the video, I'll kind of talk about that. So but we talked about cloud types. This is a cumulonimbus cloud. Of the 10 types, this is cumulonimbus. It's fluffy and precipitating. There are 3 stages to a thunderstorm. It starts with the cumulus stage, and it goes to the mature stage, and the dissipating stage is the end of your thunderstorm cell. And this actually, you're going to see, it might even be this figure. So this might be even on your test, this figure right here. Okay, you just got to name the features. Okay, and I'll kind of talk you through it in the video. But in its mature stage, basically your thunderstorm is still feeding, and that's what we call the updraft, and your thunderstorm is dumping. That's called your downdraft. Okay, so basically you have both of those things going on in its mature stage. Now, if it's really unstable, really got a lot of oomph to it, you're gonna see it shoot into the stratosphere. So you told me the stratosphere's here, we're in the troposphere. Most clouds are here in the troposphere, okay? But if it's got enough energy, it will punch and you'll see these overshooting tops. You've probably seen them before, like little cauliflower tops. It flattens out, okay, it'll flatten up when it hits the tropopause. This actually, you might have seen this before. This is kind of, if you're sitting over here watching the storm roll in, okay, this is what we call a shelf cloud, okay? Yep, shelf cloud. And if you're sitting over here, you might feel actually kind of what we call a gust front, which is the wind before this comes. It's the winds that's created from the downdraft. That's a gust front. But this is kind of creepy. This is actually the warm air that's feeding it. So this is what we call inflow, and this would be the outflow. So anyway, that's that. So the 80-20, actually there's two types of lightning. The 20% of the lightning is what's going to get you. This is the cloud to ground, and this is the cloud to cloud. So not to make you feel safe around lightning, because you shouldn't. There's a lot of deaths due to lightning every year. And so as someone who's sat in on these trainers meetings that the National Weather Service puts on, if you can hear it, you really probably need to seek shelter.
I think you can be struck within 15 miles.
Yeah.
Storm.
Yeah, if you can hear it, that means that actually it can reach, it's like, well, I don't really see it near me. It can extend.
So you're saying 80% of the lightning goes from cloud to cloud,
Mm-hmm.
and 20% of the lightning
Yep.
reach here.
Yep. And if you feel your hair start to your tingle, there might be a charge being created in your.
Are there some people who are more like receptive to being struck by lightning than other people?
I don't think so.
No.
But I've heard things like that,
Yeah, because
so.
I've heard people
I
who
don't
like
know.
get struck a lot. Like,
Yeah.
I've been struck like 3 times.
You're
and
like,
there's people who's like, I've never been struck.
How does that
And it's
happen?
like, yeah. And then people who like break cell phones because their body apparently has like my aunt, she's been struck by lightning before like something, and she breaks cell phones because of like some kind of
Current or
current or
whatever?
charge within her, where she'll break cell phones, or like people will break the batteries in their watches that won't work on them or something. I don't know. I was like, we actually talked about it today in one of my classes a little bit, and
It's interesting.
it's,
Some of those things you can't really, it'd be hard to chase it down because you can't recreate that.
yeah.
But if you observe it, I think it's interesting.
That lightning, the hair, I think I felt that one time. Across the street, lightning hit a tree over there,
Mm-hmm.
made a big boom, and I could feel my hair.
Responding to the
Yeah.
electric current.
Yeah, I just thought I was kind of freaking out. I got to thinking about it, I think that was the static from that
Yeah,
lightning.
that really
And
could have
I could feel
been.
my hair kind of move, I thought I was just freaking out. But I think it was, I think I felt my hair.
Because with a bolt, there's a volley back and forth of electrical current very quickly. But
Yeah, I think I felt that. It was close enough. It was right across the street.
well, we're glad you lived to tell
Well, if
about
a
it.
lightning bolt hits you, doesn't it go like through your body like over 1,000 times?
I don't know about that. It could be. I don't know.
Is that what you were talking about with the volley?
Well,
Twice a
one
minute.
stroke actually is a really quick, kind of back and forth of electrons in the same path. So that's what I was talking about.
Okay.
You've been turned off again.
What's that? Oh, drat. Well, the last thing, I'll just tell you what it is. The last thing is heat lightning, and it's kind of, people think, well, heat lightning is because it's hot outside. But actually, heat lightning is normal lightning, but it's just so far away that you can see it, but you can't hear it. It's heat lightning that you just can't hear it. And you can read on my notes, it says, see it but don't hear it because it's too far away. So the light can get to you, but the sound dissipates. And I think it's like maybe 15 miles or so. So goodness gracious.